Hi guys, welcome back to Algebra 2 Easy. If you have struggled in the past with the unit circle, you will not struggle anymore after this video. Your teacher ever tell you that as long as you know quadrant 1, then you know the entire unit circle. So today we're just going to focus on quadrants 1 and 2. And then tomorrow, make sure you come back and then we will go through 3 and 4. Those special right triangles and those trig ratios with those triangles from last week, well, that information is going to be used here. So we think about it, we had a 30, 60, 90 degree triangle. We also had a 45, 45, 90 degree triangle. Well, if we think about the lowest amount out of those angles, it was 30 degrees. Well, that's going to go right here. Then 45 would come next, then 60, last 90. Now, we do start with 0, so make sure you go ahead and put 0 as your lowest angle. We're going to go ahead and talk about the ordered pairs. We're used to our ordered pairs being in the format of XY. Okay, it's still in that same format. However, they're going to mean a little bit more this time. So if you're finding X, you are really finding cosine of an angle. If you're finding Y, you're really finding sine of an angle. So let's do that. If we start off with 30 degrees because we dealt with that triangle, that 30, 60, 90. Let's go ahead and start with 30 degrees. If we're finding cosine of 30 degrees, okay, let me pop that triangle back up from last week. Notice we got radical 3 over 2. When we found sine of 30 degrees, we got 1/2. Now let's go to cosine and sine of 45 degrees. If you remember from last week, and I'm going to pop it back up here, sine and cosine, okay, they were the exact same because in those 45, 45, 90 degree triangles, those side lengths were the same for your legs, okay? So that's why they always, doesn't matter what your legs were, it always simplified back down to radical 2 over 2 and radical 2 over 2. Now, cosine and sine of 60 degrees. Let's talk about that. Remember, cosine of 60 degrees is 1/2. And then sine of 60 degrees is radical 3 over 2. Okay, if you don't know any angles and what the cosine and sine of them are, make sure you know these. Because once you know these, you have everything else. Now, let's talk about 90 degrees. We didn't have anything really special about 90 degrees, also at 0 degrees. However, it's very simple. Our radius of the unit circle is 1. So our radius is 1. So for 90 degrees, notice that you're at the origin. You're not moving left or right. You're only going up 1 unit. So your ordered pair is going to be 0, 1. Now for 0 degrees, so we're only going to the right. So it's going to be 1 unit to the right. And then 0 for the Y value because we're not moving up or down. So you may notice we do have extra blanks. And you may be wondering about what goes in those extra blanks. Well, that's going to be radians. So earlier, aka yesterday, we taught you how to convert from radians to degrees and also from degrees to radians. However, you may not have time to do that. So there is a little shortcut with these particular angles, okay? So if we start off with 30 degrees, you would ask yourself, because we're going to 180 degrees, you think about a triangle, okay? We have the highest we can have, all angles add up to be is to 180. So if we look at 30 degrees, and I think about what can I multiply 30 degrees by to get to 180? Well, you would say 6. Well, in radians, it would be pi over 6, okay? Now, moving on to 45 degrees. Same thing with 45 degrees. I'm going to ask myself, what can I multiply 45 by to get to 180? Or when I divide 180 by 45, okay? Well, you get 4. So it's going to be pi over 4. Now, we're going to do the same thing with 60 degrees. I need to go from 60 degrees to 180. So that means I can multiply by 3. So I'm going to have pi over 3. Same thing with 90 degrees. To get from 90 degrees to 180 degrees, I would say 90 times 2. Well, that's going to give me pi over 2 in radians. Now, let's go to 0 degrees. Okay, If you're writing 0 degrees in radians, it is just 0. It's that simple. Because remember, 0 times a number is going to give you 0. Moving on to quadrant 2. First, let's talk about the angles in quadrant 2. You know, I told you as long as you know quadrant 1, you have quadrant 2. Well, here's why. You know, if you have a straight line, we learned this in geometry. So for a straight line, we know that that angle is 180 degrees. Okay, so let's put that here. Now, what you're going to do is you're going to take these reference angles of 30, 45, and 60, and you're going to subtract them from 180 to have those other three angles that you see above. Okay, so I'm going to say 180 minus 30. Well, that gives me 150. I'm going to say 180 minus 45. Well, that gives me 135. I'm going to say 180 minus 60. Well, that gives me 120. Now, that could go the same way. You could have started up here at 90. You could have said 90 plus 30. Well, 120. You could have said 90 plus 45, 135. You could have said 90 plus 60, 150. Okay, so they correlate. Now, we move on to us dealing with the ordered pairs. Okay, what you're going to do is you're going to ask yourself, if I decided to fold this particular unit circle in half, okay, hot dog style, I mean the long ways, fold it in half, you would ask yourself what angles would line up with each other. Well, that would be 30 degrees and 150 degrees. Okay, if you fold it in half, they would be on top of each other. Well, their ordered pairs are going to be the same. So it's going to be radical 3 over 2 and also 1/2. Now, that works the same way with 45 degrees. If you folded the paper 45 degrees, will land on 135 degrees. So that ordered pair would be radical 2 over 2 and radical 2 over 2. Then we do have 60 degrees would fold onto 120 degrees. So that ordered pair would be still 1/2 and then radical 3 over 2. Now, someone may say, well, you're in quadrant 2 and everything's not positive. And I agree with you. You still think about if you're actually plotting points because it is a coordinate plane. So if you're plotting points, that means you would be at the origin and you would be going to the left and you then would be going up in quadrant 2. So that means that all of your x values should be negative. And that's going to be the only difference between quadrant 1 and 2 as far as your ordered pairs go. Now, let's talk about the ordered pair for 180 degrees. Remember, we just talked about that radius being 1, but this time you're going to the left to get to this point. So it's going to be -1, 0 as my ordered pair. Now, radians is still very simple. With 150 degrees, it's going to involve pi over 6 because 30 involved pi over 6, okay? However, these are not the same, but I can actually multiply 30 degrees by 5 to get to 150 degrees. So that means that my radian is going to be 5 pi over 6. So notice how pi over 6 is still used, but then I'm still trying to equal 150 from 30. Now we're moving on to 135 degrees. It matched up with 45 degrees. 45 degrees was pi over 4. Well, 135 degrees is going to have pi over 4 in it, okay? However, like I said, 5 degrees and 135 degrees, they're not the exact same numbers. But I can say 45 times 3 to get 135, so it's going to be 3 pi over 4. Last, we have 60 degrees and 120 degrees, okay? They matched up. 60 degrees had pi over 3, and so will 120. Okay? However, 60 and 120 are not the same number, so I would ask myself, what can I multiply 60 by to get to 120? Well, that's going to be 2, so it's going to be 2 pi over 3. So 180 degrees, we can refer back to 90 degrees, okay? 90 times 2 is 180. Pi over 2, we're going to multiply that by 2 to get just pi. So 180 degrees in radians is just pi. Well, that's it for quadrants 1 and 2. Come back tomorrow to see how we are going to learn quadrants 3 and 4, still using quadrant 1.